Hello, everyone. I'm Bob Sanheinrich. I'm a software developer here at Wolfram, and I'm going to be talking about the development of this tutoring platform that we're making with Wolfram Technology. I should be joined by Theodore Gray. Very little bit of background before I go to a demo. So we are building what we're calling a personal education system, which is you can think of as sort of a tutoring environment, sort of a traditional tutoring environment that guides a student through a course. And we're building this using a lot of different pieces of Wolfram technology. So we're using private clouds and notebooks and LLM integration. And we think that this is a very, useful development flow and sort of paradigm for building a product with our technology. So we kind of want to share that to us. But before I dive in any deeper, I'm just going to do a demo. Let me leave full screen here and bring my browser over. So this is sort of a student's view of the product that we're making. So this is sort of like a table of contents. You can think of this as like a textbook table of contents. The course that we're working here is sort of an introductory algebra course. And you can see all the different chapters that we have. And I can go to one of them here. And you can see it sort of starts with material that that might look like you would see in a traditional textbook. But what's new is it has these opportunities to talk to the book and get answers, and the book can ask you things, right? So and then LLMs allow us to make this actually work well. So here's asking me to give it more points to see what points look like on the number line. So I can tell it to add -2 to the number line, and it'll regenerate it with -2. Oh shoot! Okay. I can say make a rainbow with many points, and since there's an LLM behind this, we didn't need to build in any knowledge about how to parse statements like this. It can just do it, and it has all these tools to control the points, right? It knows how to specify locations and colors, and then the cloud in the background generates the graphics and sticks it right in. So we've built this course with Teo and in consultation with Jerry Glynn, who's sort of a domain expert here. And we have this large algebra course. Another feature that we have here is these dynamic tools. So in this case, this is an embedded cloud notebook. So you can, it's actually, it's a dynamic module, but you could think of it like a manipulate, where you can actually interact with it. And I can choose values here, and I can send that, and it will tell me that I'm right. Let me just go through and solve one more problem correctly. So let me do that. Let me finish up this chapter so we can just see a little bit more. So I want to do 7-2. Actually, I might need to do one more than just one more correctly. It might want to move me into the hard problems before I can move on. Yeah, it wants me to do the hard problems as well. I'm gonna go ahead and finish this chapter though. Just take one more minute. I'm gonna try to get them all right to hurry, because we don't have a ton of time.
I think this chapter you actually have to do a bunch of these correctly.
Okay.
Not sure how long it'll take you to get out.
Well, it's telling me one more again. So let's do one more. Now I have to do negative. This one's becoming hard. I definitely got that one wrong once when I was practicing yesterday. All right, so now it should, okay, so it tells me that I've done, it says, what did I learn? I said I learned how to put points on a graph. And I can send that to that. Send. All right. So this is sort of a nice feature we added where, you know, forcing a student to summarize what they learned really helps them remember it. And then I can go on to the next chapter. So that's sort of the student's eye view of this product. All right, I'm gonna go back to my slides here. So now I want to talk about how this thing is made and you know, how you can make similar products. And Theodore will definitely look at more of the features that we've actually built, and we can definitely do questions about the tutor itself at the end if we have time. But I'm just going to kind of go into the product. So this is a big, complicated diagram. I'm not going to dive into too much, but the point of it is in the center, we have what we're calling the tutor engine, which is a Wolfram cloud, just like the Wolfram cloud that hopefully you've used, but it's a private version of it on its own server with its own domain. And it also has installed on it a packlet of code, just like a packlet that you might use in desktop Mathematica. It has functions in it, and those functions are each exported as an API that can be used by any interface. We were just throwing a browser interface, but we also have plans for or implementations of many other interfaces. And each time you send a request, it sends messages to several different LLMs, which could all be the same model or it could be different models, to not just kind of have the conversation about your answers, but to also check to make sure that you're actually working on the task at hand, or see if you should be redirected to some other course material, or see if you're ready to move on to the next chapter. Different sort of specific tasks are allotted to different LLM models. And then there's also a database and sort of normal product development stuff. And here's a written description of basically of the diagram above, but I'm not going to focus on that because I kind of want to move on to this. So this is basically the whole workflow that we're using to create the server side of this tutoring product in a nutshell. So the first thing we do is create a packlet, and so you can get started on that with this create notebook and packlet resource. And I gave an entire tech conference talk about creating packlets maybe 3 years ago, so I'm not going to do that again. Go find it on YouTube and watch it. So instead, I'm going to show this packlet definition notebook that I've already made. So here I have a packlet. This is the name, and it's very simple. Here's all the code that's interesting. One function that's called make art. All it does is generate these mandalas. So if I run this, you can see there's one function, and that's all it does. So now I could build my packlet and deploy it to my cloud account, and that would take about 3 minutes that I don't want to spend. But so I've already done that. So I've already built the packlet and I've deployed it to my cloud account. I didn't publish it in the packlet repository. I just put it in my cloud account, which is all I really need to do here. So here's the packlet's homepage on my cloud account. So this packlet is available for anybody who wants to use it. And it has this convenient packlet install code right here for me. So I'm going to go back to my slides, and you can see this packlet install is right here. So all I do to install this in a cloud is do cloud evaluate of the packlet install, right? And now that packlet is available in my personal cloud account. For the tutor, I would be using our private cloud. But in this case, I'm just using the normal public Wolfram cloud. Now I'm going to create an API for my one function. So this API, all it does is it loads the packlet, it calls make art, and it exports it as a PNG. So now I have this public API. I can go there, and you can see every time I load it, it's creating another image. Now I'm going to create a second API function, which is just basically wrapping this API location in JSON, because JavaScript web pages love to work with JSON. So now this is the simplest API you can imagine. It's just static data with one thing. Now I'm going to create a web interface to call the API. So here's some HTML code wrapped in XML template with some slots. If you've done any web coding, you can tell that there's nothing really complicated going on here. There's a little bit of JavaScript just for making an HTTP request. There's a title, there's this loading image. So now I can apply this template to some data. I'll tell it where my JSON API is. I'll give it a title. I'll insert that loading image, and that creates HTML, just a string. And I can export that to the cloud as well, tell the cloud that it's HTML, tell it where to put it, and make it public. So I've done that, and now I have this web page, which is a standard web page anybody can use in a browser, and it's pulling in every time somebody loads this page. It calls the cloud API, which loads the Packlet, which runs the function, which generates an image, and exports it all back out here on each page load. So in essence, this is the entirety of sort of the server side piece of, and the web front end piece of the Tutor project. So it's taking all that computational ability of Wolfram Language, and anything we can write in Wolfram Language, we can then make it appear on a standard web browser that is mobile friendly and really convenient for a student or any end user to use. With that, I will turn it over to Theodore, who is going to show some of the more advanced features that come along with this development workflow.
Hello, can everybody hear me? There, oh,
yes.
There's my video. Yes. Cool. Yeah, so that's very impressive. I wonder why it took us 2 years to do this, considering that you just did it in 10 minutes. But there is a little bit more detail. I mean, for example, you saw the the very slick, beautiful behavior of the student interface, where it's putting up nice rounded corner rectangles and interacting with an LLM. That's all quite a lot of JavaScript code. Obviously a lot more than what Bob has written. And the back end is quite a bit more complicated. There's a whole lot of stuff going on to manage student interactions with the system and log files and all these chapters and everything. And then there's a whole other component, which is the desktop development environment in which the courseware that this system deploys is developed. So I'm going to show you mostly the desktop side of things. And let's see, can I share my screen? Share screen, send request. Somebody has to approve this apparently. Okay. So, choose screen. I only have one screen. Entire screen, share. Okay. And now I guess I probably want to hide this. Okay, so hopefully you're all seeing a dashboard that says my classes and my classrooms. So just to give a little overall framing. So the way this is working is student works on a website. They just go to their browser, they do stuff with a website. It goes to this API that is communicating with kernel-based, we have an EPC, enterprise private cloud thing set up, a little mini cluster, bunch of kernels there that are servicing these API requests from the student and building up log files and state and such on the server. What this is showing you, this is it's desktop Mathematica running on my machine, which is calling in some cases exactly the same, in other cases related APIs on the same server, accessing the same data. So it can see and show you the state that the student is working on. So for example, I have a classroom in which I am registered as the teacher and Bob is a student. So here, these are all the other students in this little classroom. And if I want to see, so I can click here, this is now going to open the session that Bob just did, except, you know, it looks kind of similar if you remember what it looked like, but it's not a web browser. It's not a web page here. This is a Mathematica notebook. And let's go look at the chapter he just, and we'll get to these little sentences here in a minute. So now I click on here. So I'm now going to open the same chapter he was just working on. And it's slow because it's going to the web and getting the data. Okay, so here we go. Let's ignore that for a second. So here is what Bob just did, except you notice it's got cell brackets and it looks a little, well, it looks a lot less polished, and you know, it's a notebook, but it's also got a lot of extra stuff going on over here. So I call this the stoplights area. I don't know if you can see my cursor moving around to point it out, but you see this thing that looks like a stoplet. Okay, so this gives you lots and lots of information of sort of behind the scenes what happened when Bob said, make me a rainbow. So for example, it cost 0.72 cents. So, you know, 3/4 of a penny to execute 5 parallel LLM processes. They're a mixture of, and just right now it's set up, it's a mixture of GPT-4.1 and 4.1 mini. The conversational, the first line item there, that's actually the thing talking to the student, and is the most expensive one, costing almost half a cent. And then the other ones are doing these sort of side tasks that are used to keep the conversation on track and, you know, just sort of manage things and make sure things go in a sensible direction. One big question when a student is using a system like this is, are they even paying attention? Are they just rambling? Are they, you know, are they focused or not? So we have a thing called focus task. This mouse over here, this shows the complete prompting that was sent to the LLM to evaluate whether this response is on topic or not. And then this is the response. You might think that saying make me a rainbow isn't very relevant in a math course, but it's a beautiful thing about the LLM is that it recognizes that in this context, in this very specific situation, make me a rainbow is actually extremely relevant. It shows that they're, you know, the student is really thinking about it and has kind of a creative response, like, oh, I've got a line, I can put points on it, I can change the color, I could make a rainbow. That's like a very high level of engagement with the material, much beyond what you'd expect of a typical student. But you know, Bob is a great student, so and the LLM recognizes that. It doesn't say wrong, you know, get back on track. It says, wow, that's, you know, this student is really understands what they're doing. So, you know, so there's these different things. There's moderation task, which is just basically, you know, is this like a dangerous thing? We need to not answer. The student doesn't see any response until it's passed the moderation and safety passes. There's the focus. There's progress is not invoked here. This task is scanning for, you know, have they told us anything about themselves that we should remember? And the off-topic task is, you know, did they say, well, what about quadratic equations? And in that case, they would get a little panel pop up which says, oh, you're interested in quadratic equations. Here we've got a chapter, you know, or several chapters that you might want to go to. So, you know, it's what's going on behind the scenes is much more than just an LLM responding. So the other thing that is different from a typical LLM is that you notice that this is not a situation where the student asks a question and the LLM answers it, which is what pretty much everyone's sort of tutor bots are. It's like it's homework doing. It's kind of like Wolfram Alpha with wrong answers or whatever. That's not what teachers do, right? Teachers don't just have a class and then say, well, what are your questions and I'll answer them. That's not the role of a teacher. Teachers ask questions and then the student is supposed to answer them. And teachers ask a targeted sequence of questions that is, you know, carefully designed to elicit, you know, sort of a sequence of understanding states in the student. And it's, you know, it's sort of a very non-trivial problem. What questions do you ask the student and in what order? So if you want to have an actual teaching bot as opposed to a question answering bot, you have to do a lot more detailed work. You need like the curriculum. I mean, the goal here is this particular invocation of it is going to teach the student beginning algebra. And it's good, the whole course, you know, start to finish. That's a lot of detail. Like, what does that even mean? That depends on what country you're in, what, you know, what state even maybe. it's something that needs to be sort of built into the system, that it knows what does it mean to teach Algebra 1. In other words, it needs to have embedded within the system a textbook, a teacher's manual that explains how to use the textbook, tools like the interactive graphical input that Bob showed you. And all of this needs to be sort of set up and configured and adjusted in such a way that an LLM can use it as actionable information. This is done with what is called a course notebook. So if I go to, for example, let's see, if I go here, this one here. So I click here. This is now opened. You see this is Algebra 1 V1. So this is the course notebook. This is a very large document. If you, I tried like virtually printing it out. It's like 400 pages long, something like that. It's the complete layout of this course. And by clicking on that T button, it's taken me to the introductory text section. So obviously this is a notebook. And you see there's various, it's a mixture of plain text, and this is a tool invocation, which says, you know, call up this tool. In the same way that like the LLM can call up the same tool, the interface to it is JSON, because that's what LLMs really like to speak. And then there's these sort of little editing lozenges, which are things that they're just, you know, signals that turn into things that look quite different to the student, but they're sort of invoking functionality. And if we go back here, so this is like literal text that you know translates into the introductory material. Again, we're going to get to that in a second. And then let's say, you know, let's say the students had something and the LLM answered, and it, you know, and the LLM just screwed up and said something stupid, and you don't like it, and you want to fix that. So what do? Well, you click on the P button, which stands for prompt. So this has now taken me in the source code to the local prompting of this subpart of this chapter. So there's a, you know, the whole tower of prompting. These are references, they're kind of like subroutine calls that reference larger blocks of prompting. These are different sections of the chapter where there's more specific prompting. Tool references, which instruct the LLM on how to use the display utility tools, like the plotting tool. You know, it's like basically it's source code. And developing the course is essentially like writing a piece of software. It's a software engineering challenge. And to do that, you want to have an IDE. And so, you know, the way that I think about the thing that we've built on the desktop side is as an IDE for courseware development, in the same way that, you know, Visual Studio or whatever is an IDE for C code development or whatever language. And, you know, the stoplights area, this is one aspect of it. This, you know, these buttons let you skip around in the source. They let you evaluate. You know, if it completely screws up, you might click here, and this is now showing you every word, literally, you know, word for word, character for character, exactly what was sent to the LLM. And maybe you look in here and you'll see, oh well, so, you know, software screwed up somewhere. It didn't pick up some fraction of prompting it was supposed to, whatever. You look at the response, maybe it was the LLM's fault. Here, yeah, so here you see a response where the LLM has written some text, but it's also written a JSON table, which is recognized by the receiving end, either web or notebook, recognized as a tool invocation, and then the appropriate piece of Mathematica is called. Anyway, what I was glossing over there is that, you know, one of the really nice things about the system is that when it's thinking about how well is the student doing, it's not limited to, for example, they did a 10-question multiple choice quiz, what score did they get? Which is typically what, you know, educational software relies on, is this sort of very shallow, low bandwidth sort of numerical scores. This thing has been talking to the student potentially for hours and watching the mistakes they make. Anyway, this is an example of a simple interactive tool. It's a combination of prompting that instructs the LLM how to do it and Mathematica code that actually implements it. And that means we can now look at the summaries. So this thing has been talking to the student, and therefore you can ask an LLM, potentially one of the expensive sort of deep thinking LLMs, all in this case it's just 4.1, GPT 4.1, that is doing it, ask it to write a summary of what's up with this student, like how did they do in this section. Now Bob is a very good student, and this is a lot to write about. Like, this is probably too much. I should probably tell it don't write quite that much, because there's not much to say about this chapter. But it's written it's written a summary, and that is then used, that summary is then used to give you, let's see if we open here, to give you a 1-sentence summary. So if he'd completed more chapters, you would have more sentences here. So this will, this allows, because I'm viewing this in teacher view, it allows me to get an overview chapter by chapter. How is Bob doing? In here, there's a virtual TA. This is a thing where I can talk to the LLM and ask it questions about how Bob is doing. And it in this section, it has access to the complete chapter logs and to all the summaries. So I could ask, how did he do on quadratic equations? Did he get this problem right? Whatever, it can figure that out because it has access to all of that data. And then the next level up is in the user dashboard. If I'm a teacher,
we got a couple of questions.
Okay. Anyway, just the very last level here. So this is summaries of all the different students, except we wiped the database accidentally, so we only have one summary. But yes, how are the questions going?
All right. So Jason asked, how flexible is the framework that you've built? The course notebook looks intimidating for an educator to assemble. I think if you were starting from scratch, I think creating a new course in a course notebook, you should plan to work on it for, weeks to months, right? Because it's just like writing a textbook, right? It's hard and takes time.
Yeah, it's like writing a textbook.
But one feature that we've had that we didn't have time to show is you can make additions or addenda to an existing course. So any teacher can go in and add notes that the students will see throughout a course, or even add prompting that will affect how the LLM responds within specific to a chapter or a whole course. So that the existing material can kind of fit their preferences and their needs.
Yeah, and I think this is a very important thing. Like, not very many teachers write their own textbook, but a lot of teachers say, we're not going to use pages 37 through 39. Here's a handout because, I like this better. And they can do the equivalent of that in the web interface. They don't have to use Mathematica to do that. We have a web interface that lets them annotate and add to the courseware. And I think a lot of teachers are reluctant to put their students in front of some chat bot that is created by some giant mega corporation that they have no control over. Like, what's it going to say to them? There's nothing you can do. It's like OpenAI is in charge of that, or Khan Academy is in charge of that. You can't fix it. This thing, the teacher using a web interface, not Mathematica, just a very simple web interface, just a little bit more complicated than the student, can go in and add detailed prompting at every different level, like globally per chapter, per chat opportunity within a chapter, and just modify what it's going to do. And you try this, it's remarkably responsive to that sort of instruction. So it gives teachers a lot of agency that they don't have in other sort of AI situations.
Okay, and then one other question, which is fairly similar. Phil is asking, how high is the expertise threshold for authoring? Would one need to become an expert in prompt engineering before beginning to contribute? I think not. So, I mean, it was for the very first time, right? So like Teo had to become an expert on prompt engineering to make it. But I think a lot of the prompting we've written for the first course, and we're making progress on a second and a third course, it's going to be fairly modular and transferable. And so I think that, for new courses, it depends how different they are, right? So I think anything in the math domain, a lot of the prompting is going to be reusable, and you won't have to even look at it or think about it. If the fourth course is something way out of left field, then probably it would take a lot more from the ground up work. But the more courses we have, all the prompts will be fairly modular and reusable, and I don't think people will have to do a lot.
Yeah, and just sort of philosophically, my attitude about this is that base model LLMs, like there's billion-dollar companies, trillion-dollar companies spending billions of dollars every month trying to make these LLMs respond more like a human would to instructions. And so, and they're really good at it right now within the, the limited scope of what they can do. So you just kind of tell it what you want it to do. And very often that just works. Prompt engineering at this point for this level and where you're doing this sort of very localized, sort of hyper local prompting, it's really not that complicated. You kind of ask it what you want it to do. And over time, it's been getting better and better. Like each successive model does a better job of doing kind of what a human would do if they were given the same instructions. Like you could give this course notebook to a human teacher and say, teach the course, and they could figure it out, right? So, and that's going to become more, that will be more and more the case.
The tool creation of Wolfram Language, obviously, is something that you
that's a program.
need to be able to write some code for. But
just like if you're writing a paper textbook and you want a fancy illustration, you need an illustrator. You know, there's technical aspects to this that may require specialists, and
one more question before we wrap. Have you any evaluation results from testing this with students? We do. We've had some trial students, not a lot, but the system keeps evolving. So we did a significant bunch of testing months ago and learned some things, and we've kind of been not soliciting testers as much as we've re-implemented some things, and we'll probably do another run with the latest stuff here soon.